Hello everyone and welcome to Simplify Square Roots. This is a Khan Academy exercise. You may find this in geometry course, in an Algebra 1 course, Algebra 2, or advanced topics. So let's go ahead and get started. So we're asked to simplify the square root of 18 and we need to know what that means. Khan Academy gives a great hint. It says remove all perfect squares from inside the square root. That is one of the conditions for having a square root, for example, or for simplifying a square root. For example, if we had square root of 25, that itself is a perfect square, so we need to reduce that to 5. Okay, so that would be simplifying square root of 25, writing it as 5. The other conditions are there can't be fractions inside the radical, and there cannot be a fraction for a denominator. So that's just kind of the basics of it, and now I'll break it down into how we go about this. One of the quick ways to do these problems, and this is the way I like to do once I become more familiar, is to look for or think of perfect squares that are factors of 18. So if I think of the perfect squares, the basic ones are 4, 9, 25, 36. Okay, those are all perfect squares. So you're going to be using 4 and 9 a lot in terms of looking for perfect square factors. But you could get up to ones like 25 and 36. So are 4, 9, 25, or 36 a factor of 18? And of course we see that 9 is a factor. So we're going to list that as one of our factors inside the radical. And then what do we multiply 9 by to get to 18? Well, we have to multiply it by 2. This is true because we can write square root of 18 as the square root of 9 times 2. That is true. So we just kind of split it into two radical signs, and I'll show you why. Well, the reason why we do this is because radical 9 can be simplified into 3. Square root of 2 cannot be simplified any further, so it is just 2. Okay? So our answer for this one is just radical 2. Now, the other way to go about this is, and this isn't always the most efficient way, but you can do this for any problem, and it especially comes useful in bigger problems, is you can use a factor tree. So if I put square root of 18 here, I'm going to use a factor tree to break it down into its prime factors. So I always like to divide by a prime number on the left, and then I get an answer on the right, and then obviously there's two prime factors that multiply to this one. Now this is how I like to think of it. I like to think as the radical as a house, okay, and then all the factors inside as the people in the house. So I can rewrite this as hold on, let me do this. 3 times 3 times 2. So 3 times 3 times 2 is the same thing as square root of 18. Okay? Now, when I have a pair, and I'm talking about square roots, one of those 3's can leave the house. So 1 3 is going to come out as a result of this. 1 3 is going to escape the radical, but the 2 is going to stay home alone because he doesn't have a date, so to speak, okay? There's only 1 2, so I put a box around him. He stays inside the radical. One of the 3's gets to leave because he has a date. So I could rewrite it as 1 3 escapes, 1 3 leaves the house, the 2 stays home, and I get the same answer, okay? So I'm going to go ahead and write 3 radical 2, 3 radical 2. Okay, let's go ahead and do the next one. Here we go. So 72 might be a little more tricky to think of perfect square factors, but again, you're limited to really 4, 9, 25, 36. So if you're looking through those 4 initially, obviously you see that 36 is going to be your perfect square factor. And what do you multiply 36 by to get to 72? You multiply by 2. So then we get 6 radical 2. It's not always obvious that it's going to be that easy, though. So sometimes it is nice to be able to use a factor tree. Okay, so if I do that, I get 2, 36. And now let's say you're using a factor tree, and then you're factoring, and you notice that one of your factors is indeed a perfect square. You could stop there because you know that you could rewrite 36 as 6 and 6. And 1 6 could leave the house, and then you're left with 2 home alone, okay? But let's say you didn't know that, you weren't able to recognize it that quickly. Oh, and if you need that repeated, just rewind, watch it again, okay, pause, because that might be something you need to get a second look at, okay? All right, but in the meantime, I'm going to continue factoring, and I would like to put my prime numbers on the left as I'm factoring, 2, 18, 2, 9, 3, 3, okay? So now how does this work? I have multiple numbers here. It might be a little bit more complicated. It's not much more complicated. So I still circle anytime I have a pair. So I have a pair of 2s. 1 is going to leave the radical, leave the house. He has a date. I have a pair of 3s. 1 is going to leave the house. He has a date. This 2 is home by himself. Okay, so if you have 2 numbers leave the house, you multiply them on the outside of the house. And if you have 1 or more staying home, you're going to multiply them inside. In this case, there's only 1, so he stays in. 6 radical 2 is our answer. And that's the same thing we got using the other method. So I'm going to write 6 radical 2. And I'm going to check it. Okay, I'm going to do one more just for clarity's sake. We have another one. I hope you recognize that it is 10 radical 2. And if you're wondering how I did that so fast, think about the first method. I think of perfect square factors, okay? But we're going to check that using the factor tree method. All right, so I'm going to do 2, 100. You should recognize something about 100, but let me continue. 250, 225. If you didn't get it by now, you should recognize something about 25, 5, 5, okay? I'm going to circle anytime I have a pair of 2s, pair of 5s. 1 2 is going to leave, 1 5 is going to leave, and this 2 stays home alone. So I have 2 times 5 on the outside, radical 2, 10 radical 2 is my answer. And that's what I was able to do very quickly at the beginning because I can recognize perfect square factors. I've been doing this a while. Okay, hope you guys enjoyed this video. Leave a comment below if you have any questions, and I'll see you next time.